as an example, in the textbook on page 209, has a data set of some angles to horizontal for some holes drilled in a type of high precision metal part by electrical discharge machining in a very high-tech kind of machining process. So if I have a part and here's its there's its top surface, and I drill a hole in it, so I drill a hole, I can measure the angle of that hole, the angle. I could think about sticking a little pin in that hole and then measuring the angle from the from that pin to the flat surface of the part, and that's the kind of thing that's measured and recorded on page 209. And there are, in that example data set in the textbook, there are 50 angles, 50 parts involved, and here is what those data look like. So I've got another data set here in JUMP. I have I've entered the 50 values into a data sheet, and let's analyze distribution. Here are the angles, and let's get this right. Let's lay this out horizontally. Get rid of that box plot, and there's what that data set looks like. As I said, there are 50 data points in the data set. There's a histogram. The mean is 44.1167. The standard deviation is 0.9835. And let's fit a normal distribution to these data. And so there is come on. There's what I get when I ask JUMP to fit a normal distribution. And now let's put a normal probability plot on this thing. And on that normal probability plot, let's get rid of those confidence limits, the line of fit, and let's put on it instead some probability labels. Now, both that histogram and that very linear normal plot say to me that it probably does make sense to think of angle to horizontal at which these holes get drilled as being normally distributed, at least measured versions of that as being normally distributed. And that's what we're going to do then. We're going to use a normal distribution assumption, and under normal distribution assumption I can go ahead and use this kind of a formula to make confidence limits for 6 times the standard deviation. In fact, if I go back to what's on this printout, I see that JMP has already provided for me the chi-square confidence limits for sigma here and there. That is, I don't even have to do the table lookup in the chi-square table for 49 degrees of freedom. I can just read these things right off of this printout. So that means that from the JMP printout, 95% limits for 6 sigma are going to be what? Well, I can take this 0.822 degrees lower confidence bound, and I can multiply by 6 and get 4.929 degrees, and I can take the upper confidence limit of 1.226 degrees, multiply by 6, and get 7.536 degrees. And there they are, right off the bat here. There are my confidence limits, 95% confidence limits for 6 sigma, that is the process capability. Capability in the sense of, I want to know about what's the process spread going to be. It's going to be somewhere between about 5 and 7.5 degrees in terms of how variable these hole angles are going to be. So that's really very straightforward. If my definition of capability is 6 times the standard deviation, and I know how to make an estimate of the standard deviation, well, then I know how to make confidence limits for 6 times the standard deviation.